Okay, question 22. Find the equation of the tangent to the parabola y equals x minus 3 squared. Firstly, this is a parabola with a double root at 3. It's positive quadratic. And I could easily find this point here. When x is 0, this will be 9. So there's a very quick sketch. You need to be able to pretty much connect functions to a bit of a visual image or an idea fairly quickly. Now we want to find the equation to the tangent to this parabola at t, where x equals alpha. So we've got some point somewhere, alpha. It gives a point t on the curve, and that is where we want to find the equation for a tangent. So let's do that first. So to find the equation of a tangent, we need the point and the gradient. Now, the point is going to be alpha, but we also need the y-coordinate. So we've got x equals alpha, then y will equal alpha minus 3 squared. So my point is alpha and alpha minus 3 squared. It's okay, we're going to have some algebra in it. The gradient, well, we need the gradient function. So when we get to using the chain rule, that would be a far better choice for this particular question, and you may have already started that unit of work. But for now, I'm going to stick with the power rule. That's what this set of questions is about. And so then my gradient will be 2x minus 6. I want the gradient at this point. So y dash of alpha is 2 alpha minus 6. Again, we've got lots of algebraic references, alpha, alpha minus 3, and 2 alpha minus 6. It just means then we'll have a nice generic formula for the tangent of anywhere on this curve, and we'll be able to find it anywhere we like. Now, the equation of this tangent, using the point gradient rule. We're going to have some algebra to tidy up. Let's just take it step by step. y1, alpha minus 3 all squared. My gradient is 2 alpha minus 6, and I've got x minus x1, and my x1 is alpha. So let's expand this out. And see what we can tidy up with this. I've got the x terms I'll leave at the front. I'm going to mark them off as I go so I don't lose track of what I've used. Alpha squareds, I've got 1 minus 2 is minus 1 of them. 6 alpha minus 6 alpha, they will cancel out. And plus 9 on the end. Okay. What I must to do now is, I'll just write that here. This is the generic equation of a tangent at any point alpha on our original curve. We're now asked to find the x-intercepts and the y-intercepts of this tangent. Well, an x-intercept happens when y is 0. So we put 0 there. And all we want to do is isolate x. We're going to move everything away from it so we get an x equals. Now, if you're not confident with your algebra, you could, of course, have typed this in on your CAS and then just solve for x, and it rearranges everything for you. So this is my x-intercept. Now my y-intercept, it happens when x is 0. So if x is 0, those two terms drop away. Leaves me with my y-intercept is 9 minus alpha squared. They called the x-intercept A in the question and the y-intercept B. And now we need to find the midpoint of AB. Which has coordinate this one and B.